Hi, my name is Fran, and I'm one of the developers on the AR Magic Lantern project. Today we're going to give you an overview of how to use the SDK to create a simple Unity scene for the Magic Lantern. First, we create a new Unity scene. You can call it anything you want. We're calling it Presentation Demo. Once you open it, you can remove the main camera and, if you want, also a directional light. After this, you can drag and drop a prefab called Levels, or you can just create a new game object and add the level controller script into it. You should also add at least one child game object with a level script. This is already enough for clicking play. If you click play, the logic scene will automatically load alongside the new scene that you created, and you can already use the lantern. For our example, we will add a 3D scan of our lab and place objects in it. It's important to add a mesh collider to the environment 3D scan in case that you want the physics to interact with it. Also, you should set the game object to the map layer. Now we're going to look at how to set up the interactables. In this case, we're going to add a knife grabbable. Create a new object and add the script anchored grabbable, or you can also drag in from the prefabs. Adjust the script and model of the grabbable to fit your needs. Some considerations for best results is that you should separate the logic and rendering of the grabbable. You should have the parent game object contain the anchor grabbable script, a collider to interact with the camera, and an animator if you need it. This will prevent issues arising from the animator trying to update the transform of the grabbable while it's being affected by the camera grabbing it and moving it around. You should also have a model child game object with the mesh renderer and a rigid body, ideally kinematic. Placement targets allow for grabbables to be dropped and picked up at specific points in the environment. This behavior can also be activated automatically after a grabbable has fulfilled its purpose, in our case, once we have caught all the fish. Once again, you can add a placement target component to a game object and adjust accordingly, or just grab the prefab from the folder. However, the easiest way is clicking the Spawn Placement Target button at the bottom of the grabbable component in the inspector. This will automatically spawn a placement target with the same mesh as the grabbable and a reference to it. Depending on your mesh, you may have to adapt the collider. It is recommended that the placement target to also have a model game object with only the renderer and mesh filter, and to have the box collider and rigid body in the parent game object. In our case, we're going to have a knife anchor grabbable object. Once picked up, clicking the button will activate a cutting animation that affects the model transform, as well as activates a child collider for interacting with a fish. Consider how to use the 3 Unity events on the anchor grabbable component to fit your situation. For our use case, we call a set trigger on the animator to set the cutting motion of the knife. Now we are going to set up the fish interactables. We will grab the mesh for our 3-piece section fish. We add a mesh collider and a kinematic rigid body to each of them. For our example, we will detect when the knife's animated edge collider intersects with the fish, and we will animate them. Now, add a collision check to each of the fish parts. This is a component that can be used to call events when different collision types are detected. It supports collision enter, collision exit, collision stay, as well as detecting the velocity and direction of the objects it intersects with. In case you would like to create a more gesture-based interaction approach, you could check if a knife object is being moved in a cutting motion by the user, for example. Next, add a move transfer to target. This is a utility component commonly used to trigger position, rotation, and scale changes. You can use it to make an object move towards a target, or to trigger a rotation, etc. For this example, we're just going to make the cut fish parts float towards the sky while rotating to indicate that they have been successfully interacted with. Now we're going to briefly show you how to build to the lantern. You need to open the logic scene in the scenes folder. This is the main scene that handles all the logic behind the lantern, including rendering and tracking. It's also responsible for loading the correct scene when the application starts. So we need to go to the game controller object and send the reference to our scene as the scene to load. After that, we can make a build. Make sure that both the logic and the scene you made are both included in the build, and that the build target is Linux. You can then click build. When you're ready to build into the lantern, load the build files into a USB stick. Plug a USB hub into the USB-C port on the back. Connect a mouse, keyboard, monitor, and USB power supply to the hub. Once the lantern boots into the launcher, press Escape to exit to Linux. Insert the USB drive and copy the build folder into desktop/Unity builds. Open the local build folder, right-click on the executable, and choose Properties. In the Permissions tab, set Allow executing file as program. Double-click the executable icon to open the application. Next time you boot the lantern, it will show up on the launcher so you can easily select from there. That's it for the demo. Thank you for watching.